In the previous episodes, we've made all the elements of the volcanic eruption. Now let's work on the final scene, including lighting, shading, and rendering. You might notice that we haven't made the dust and the shockwave smoke in the air, as well as the fire and smoke on the ground. Actually, I'm not going to create them in Houdini because it's easier to do in compositing. In this episode, the most tricky part is lighting. Other parts are easy to handle. For a large-scale scene, I suggest rendering in layers. If one of the elements goes wrong, we just need to work on that layer specifically, rather than re-render the whole scene. But do not break it up into too many layers, otherwise it will bring a lot of trouble to rendering and compositing. The scene can be divided into 4 layers. First, the model layer, consisting of the terrain, the debris, the trees, and the lava on the terrain. Then, all the smoke except for the volcanic bombs. The third and the fourth layers, the 2 volcanic bombs in the foreground and the ones in the background. Alright, we start off with the model layer. But before that, let's analyze how to do the lighting. First of all, a main environmental light. Here we set a side light on the left, slightly backward. Besides, both the spewing lava and the flowing lava on the terrain can slightly illuminate the terrain. We'll put some fire elements on the hillside later, so some lights are needed to imitate the burning trees. Besides, you can see the crater is brighter than the other areas. That's because I set a light there, in order to enhance the atmosphere. Here is the stuff we've already done. This is the upper broken terrain, the static lower part, the static trees, and the animated trees. The debris. And then the lava. I've already made the environment lighting when shading the terrain, so directly copy it. Drop a mantra. Let's add the objects to be rendered. If we add them here, only when displayed can they be rendered. So we can put them in the force objects. Here are 2 text fields where we can set the lights. I'd like to explain them with an example for your better understanding. In this project, there is a ball and 2 lights. For the 2 lights, one is on and one is off. And then put them into candidate lights here. You can see only one light is working. Let's put them into force lights. See, the disabled light also works. Okay, I believe you got it. In this case, both lights are on, so any text field will do. I'm used 2 force lights. Lower the max ray samples temporarily. Let's render it. Disable the gradual refinement rendering. Okay, everything goes well. Let's adjust the color of the lights roughly. Shift the sunlight to be warmer a bit. And the skylight to be colder a bit. It's unnecessary to put too much effort into it because it's low efficient if we test it in Houdini. We can simply get a general effect and then tweak it in compositing, which will be high efficient. Okay, let's set the geometry light of the lava. Set the type here to geometry. Then drop the lava into the geometry object and copy as material and paste here. You may ask, we've already set the emission shader for lava and it also can illuminate a scene. Why don't we directly use the emission shader? Let me explain it with an example. Here a sphere is ready and I added an emission shader with some noise to it. Turn off its geometry light for the time being and multiply the brightness of the emission shader. You can see it's almost exposed, but it still poorly illuminates the scene. If we go on increasing the value, the shader will be completely exposed. which is not what we want. Okay, we enable its geometry light again. Though we bring up the intensity of the light a lot, the shader still keeps well. Note here, when we enable a geometry light, there will be shadows. So we need to exclude the corresponding geometry. Okay, render it. Add the geometry light of the lava here. It's too weak to be seen. Raise its brightness. Good. Keep in mind that any illuminated object cannot be brighter than the source, otherwise the lighting will be fake. Currently there is no weird shadow, so I won't exclude lava. Save the rendering image. Generally, lighting has a big influence on the rendering time. There are two key points for lighting optimization. One is to use fewer lights. Another is to exclude unnecessary illumination. If the lava makes little impact on the terrain here, it's totally okay to remove the illumination. Get into attenuation options and tick this checkbox. Now we can set the decay distance. By default is 100 meters. We can see now the lighting of the lava is almost invisible. We increase the end distance. Compare before and after. Without attenuation, it took 2 minutes and 16 seconds. In this one, it took 2 minutes and 9 seconds. It gets faster, though not obvious. But when we set the final sampling, the difference will be much larger. I think the decay distance is still not big enough. Let's raise it a bit more. Good now. It's very noisy, but ignore it for now. We'll handle it later. Let's move on. Make a copy of the light and give it to the flowing lava. There are two geos of the terrain. Let's merge them. Drop an object merge node. Put the terrain here. Then its material. Hit render. Okay, the lighting of the flowing lava works. Reduce its decay distance because the area of the flowing lava is small. You can also ignore this light if it's too faint. Next, let's set the lighting from the crater. Aerial light helps here. Here we have grid, disk, sphere, and a tube. Let's see how they work. Start off with the grid. We can see it produces an unnatural shadow, but we can rotate it somehow to stop this problem. Then the disk. It works in a similar way as the grid. Sphere light can generate a smooth shadow. Next one is tube. The shadow is not very smooth either. So the sphere light is a better choice if a soft shadow is needed. Also, the disk light can do the job as long as we set a proper direction. Okay, let me explain the parameters in the aerial light options tab. To get a soft shadow, the key point is a proper size. Keep your eyes on the shadow. As we scale up the disk light, the shadow gets pretty soft. Yet there is one thing to be noted. We move it away and raise its intensity. We can see the shadow becomes hard, so we need to raise its size accordingly. Okay, back to our scene and add a disk light. Rotate it. We hide these two geometry lights, or else they will be updated all along in the viewport and result in slow operations. So I suggest hiding geometry lights. expand it. Move it a bit. Roughly done. Let's render it and see how it goes. It's too close to the crater. Well, I forgot to add it to Mantra. Okay. It doesn't seem to work. We bring up the intensity of the light. Alright, let's revise the color to be more like the firelight. Not bad. Then we set its decay distance. Check this. Refer to the distance of the lava light, 500. Seems a bit small. Let's increase it. Good. The decay is kind of hard. Delete the middle slider. Cool. You can still refine it if it's not good enough for you. Okay, that's it for the lighting. Let's increase the pixel samples to denoise. Looks better now. The noise gets much smaller. Alright, let's render it. Okay, done with it. It took 4 minutes and 48 seconds. Oh, there's no render time of the previous image. Fine, I'll render it again. It took 2 minutes and 51 seconds. After we increased the sampling, it took 4 minutes and 48 seconds, almost 2 minutes longer. Fortunately, the noise is solved a lot. The noise here is mainly caused by the lava light, so we can raise the sampling of lava lights separately. Okay, it's done. I raised the sampling quality of lava lights and kept the pixel samples 3. In this case, it took 4 minutes and 5 seconds. When I raised the pixel samples to 4, it took 4 minutes and 48 seconds. Let's make a comparison. It looks better here, but it gets worse here, because the noise here is not caused by the light. So we increase the pixel samples again. Okay, done. Looks good overall. The render time is still acceptable. Let's bring up the max ray samples. Half a minute longer. The areas illuminated by lights get better, including here. The final compositing will be rather dark here, so it's fine to have some noise here. Next, let's set the output of lighting channels and max channels. Check Combine Emission, which will output a combined image of all the emission objects. Then add one layer to output the lighting channels of every light separately. Let's take a look. This is the emission layer. The others are the layers generated by each light. As mentioned before, we don't need to struggle with the brightness and the color of lighting because we can completely make finer control in compositing through these lighting layers. The last 2 layers won't be output, so never mind. Let's set the mask layers for the terrain, the trees, and the lava for partial color correction later. Create an attribute for these objects separately. Drop a bind node after the compute lighting. Let's call it volcanic. This name can be recognized by a mantra. Pause rendering for now. Set the output of this layer. We don't need to view details when setting the channels, so reduce the resolution for the moment. Check this box. The output res will be 1/2. Okay, the volcano channel is done. Let's quickly set the others. Okay, let's take a look. Oops, some channels were not rendered out. Well, everything is set correctly. I guess it's caused by an update failure. After re-rendering, the problem is solved. Okay, the model layer is done. In the next section, we will assemble the large plume of the smoke and then render it. Before start, we need to do some processing on these single elements. I've imported them. Here are the 4 large plumes of smoke on the top. Then the smoke on the terrain. Then 5 sparse atmosphere smoke. Here is the spreading fire. Then 4 trails. Besides, we have trail clusters and 2 trails in the foreground, but we don't need to process them since they won't be used often. For these 4 elements, we will make many copies of them. So to avoid fake repetitions, we will vary the speed or shift the animation. The plume is of very high resolution. Just one frame is almost 500 MB. Thus, the operations will definitely slow down. Let's drop a volume resample node. Change the resolution scale to 0.1. Drop a file cache node and cache it out. I set its serial number to 1 and then 2, 3, 4 for the latter ones. Drop down a time warp node. The duration of this element is 200 frames, so enter 200 here. Change the evaluation mode to by frame. Now the volume is freezed. Let's keyframe this parameter to compress 200 frames into 150 frames. Set it to 200 at the end. Then let's modify its animation graph to get an explosive beginning. Okay, make a flowbook. Good. But if you observe it frame by frame, you may find sometimes the dynamics look exactly the same in 2 consecutive frames. That's because the interpolation here is disabled by default. Let's turn it on. Jump into the Volumes tab. The velocity field is available, so here we can apply a vected. A vected means the voxel values are linearly interpolated along motion paths. This way the dynamics will be very smooth, but the calculation is very expensive. Let's take a look. Okay, solved. Duplicate the time warp node, link it to the smoke. Drop a blast node to remove the veil field, because it takes up a lot of space and it will be useless when the speed change is done. Only keep the density. Make a copy of the file cache node. Change the suffix to retime. I'll cache it later. We'll use this cache when rendering and use this one when building the scene. For faster operations, we can convert it to polygon. Increase the ISO value. Only convert the density field. Now it's closer to its original shape. Give it a color for better discerning later. Drop a switch node. And drop a null node here. Hide all the parameters on it. And create a new parameter toggle. Get it linked with the switch node. When the toggle is on, apply the original volume. When it's off, apply the geometry. Okay, we've done with the process of this element. Again, the same operations to the second element. Copy these nodes and change the serial number accordingly. I've already cached it before, so it's loaded right now. This smoke only lasts 120 frames, so we change the frame range to 1 to 120. Modify the animation graph as needed. Change the last frame to 120. Okay, let's make a flipbook. Done. Do not forget to replace this time warp node. Okay, one more copy. Switch to the manual mode. Let's make some differences for this copy. Select fit range here. Remap 1 to 150 to 1 to 200. Okay, done with the second one. Let's organize the nodes a bit. Again, one more copy. For this one, I'm gonna make it slower a bit and use it in the background. Select fit range here. Extract from the 110th frame to the 120th frame. Okay, again. Only change the end frame here to 150 for a bit of difference. Also, we can rotate them. Alter the serial number of these two copies. Oh, I made a mistake. All right. Let's see another issue. Here the bottom of the smoke is hard, so it cannot integrate well with the scene. Let's deal with it. Drop a volume warp node. Add a vector to flow node. We can make a vertical gradient which ranges from 0 to 1 and multiply it with the original density, then the result is what we want. Its height is very high, so we add a fit node to remap this gradient. Keep the destination min and max as they are. Just adjust the source min and max. Well, it's not very convenient to adjust it. Let's drop down a ramp node and set the type to float. Okay, it works. But the bottom is still kind of hard. Let's add a noise. Adjust the frequency a bit. In the noise type, some negative values on the noise appear. Let's restrict it with the fit node. Okay. Duplicate a ramp. Rename it. And then tweak the ramp. Set the interpolation to B-spline for a smoother transition. Okay, then tweak the frequency again. Get them linked and reduce it by a small value. Increase the amplitude. Also, we can adjust the offset. Now the bottom becomes random and natural. Let's see the comparison. Very nice, right? Switch to the manual mode. We move the volume knob here. Alright. Let's get down to the third element. Directly copy the process of the second one. Oh, I left a chain of nodes. Let's modify the names to make them organized. change the color, we set the second element to blue. For its copies, we can also use blue, just keep them differ a bit. That is, all the copies of the second element are blue. Meanwhile, each copy has a bit of difference. The third one, we set them to red. Okay, the last one. Simply copy the previous process. For the rest elements, we won't do it step by step since the process is basically the same. Here, I directly copy the previous nodes. Let's take a look. This is the spreading smoke on the terrain, 300 frames in total. The first copy, I directly offset its time. The second one, I just slowed it down a bit. So does this one. For the other two elements, I just copied the previous process. Let's move on to the next element. This element lasts 1000 frames. Here I offset the time. Here I slowed it down. For the latter ones, I just did the same operations, either slowed it down or offset the time. You can deal with them as per your preference. This is the spreading fire. Just offset the time. Okay, let's handle the trios. I processed one element first and then copied the previous nodes. Keyframe this value as before so that we get to adjust the animation graph to obtain an explosive beginning. For other copies, I just offset the time, so I skip the process. When building the scene, our computer will get very stuck if we directly use volume. So I suggest using instances, but there comes a problem. The instance node only supports geo, so we need to place each output node into a separate geo. Just copy an output node, drop a new geo, an object merge node, and then paste the output node here. Keep the same name here with the corresponding output node. I'll skip the settings of other output nodes. Now we can get down to building the scene. Generally, start off with the main subject since it takes up the largest area, then other small elements. Alright, let's work on the backsmoke. Create an instance node. There are 4 backsmokes. Switch back to auto update. Rename them. Display the terrain. Create a floating panel. Switch to 3D view. We can move the smoke in this view and watch the final effect here. In the beginning, we don't need to concentrate on the details too much. Instead, we quickly build up the general shape first and then tweak the details later. Start with one element and make some copies. Then use another one to break up the repetition. Okay, next let's add the erupting smoke plume. Then add a few smoke elements to break up the repetition here. All these smoke elements go up straight. Let's add some smoke spewing upward obliquely. When we rotate the direction of smokes, make sure all the smokes look like spewing from the crater. We can place some more smokes on the terrain to make the large plume integrated well with the terrain overall. Alright, that's it. I won't do it one by one. Let's take a walk through. This is the spreading fire on the terrain. Hide these smokes for now. Well, it's a bit frozen. Let's make a flipbook. Alright. We can get a nice effect as long as we mix these elements randomly. Here the key point is to intersperse the high-speed ones with the low-speed ones to get a natural animation. These are the spreading fires. Do not place too many, otherwise the final result doesn't look good. A few fires scattered on the terrain will do. Another issue is that they are pretty regular in shape. When placing, we can bury the front tips under the terrain somehow to avoid a regular look. These are the sparse smoke elements. We also make them interspersed with each other.